This portion of the benchtop module that you see houses a scope for connection to virtual oscilloscope. It also has two channels, so simultaneously you can view two channels of signals from the prototyping board on your screen in the computer. It has a FGen, which is also called the frequency generator, whose job is primarily to generate arbitrary signals of different shapes. You can generate square waves, triangular waves, sinusoidal waves. You can control the frequencies of these waves either through software or through the benchtop module, where you have a frequency control knob here. All right. I also should mention the voltage, the variable power supply available here. Its magnitude can be controlled through knobs available here. It can also be controlled virtually through the software, which we will show you in a minute. Okay. Now, the first thing when you want to do when you get the Elvis board is to make sure it has two wires plugged into it. One is the power cord, which is right here. This is the power cable. You should ensure that it is plugged in tight like that, and it should also be connected to the computer through this USB cable that you see here. This is the USB cable that is primary connection to the computer, and this is the power cord. Okay. Once we have the USB cable and power cord connected, we can turn on the power to the prototyping board using this switch here that you see. Okay. There is also a switch at the back side here, which is the power supply for this benchtop module as a whole. So you first want to make sure the benchtop module power supply is turned on, and when you turn that on, you will see these two lights go on. That is ready and active. Active is an indicator, an LED indicator to indicate connection between the computer and the benchtop module, while ready just indicates the benchtop module is ready for any measurement and so on and so forth. So we will first see how to make a simple voltage measurement using our NI ELVIS module. Okay. Here we go. We have a 15 volt pin here. This portion of the prototyping board that you see has a breadboard module, where the portions that are between the plus and minus signs are the areas called component areas, and you will mount all your components in these areas. It has two columns, plus and minus, that you can see here. This is for connections concerning power and ground. So it is recommended that you use all your power supply connections to the plus sign and all your ground connections to minus sign. There is a note about how these are internally wired up. As you can see here, A, B, C, D, E in the component regions are all internally connected horizontally. That is to say, they are all equipotential points. It doesn't matter whether you connect a node at A or B or C or D or E, they're all the same things. The same thing applies to F, G, H, I, and J. They are all internally wired. And this is repetitive in the subsequent columns here and here. All right. As far as the plus and minus sign goes, it is connected column wise. That is to say, all these points along this column under plus are connected internally, and all these columns along all these points along this column under minus are connected internally. So you can use these points for ground. These portions on the extreme ends are special purpose pins or special purpose extensions, which basically are ports available for connection of voltages, input-output ports, data ports such as AI0 through AI7. These are basically sense signals for measurements from any of the internal nodes in the breadboard, and to apply excitation or stimulus from the banana plugs that you have, banana A through D, to the circuitry. So as you can see here, there is a plus 15, minus 15 ground, and plus 5 volts. These are the actual power supply pins. You also have banana plugs A through D. So these 4 banana plugs that you can make external connections using banana cables like this, these have internally connected, that is through this PCB they are connected to one or more of these breadboard points. So that will help you in wiring up the circuit without having to take it external. So this is a very convenient slot available to make any connection. It is highly recommended you don't use any of these portions to actually make your connection or mount your components. You should use only the component areas for mounting your components, and these are only for external connections. Okay. As I said, we will show you a simple voltage measurement here using the digital multimeter. So we'll take from the plus 15 point, we'll insert a cable, a single strand wire with one end at plus 15 and the other end goes to the power point plus, okay, as you can see here. Then we will take a negative one for the ground, and plug it in here right next to it, which is basically the negative one. It's also a good idea to have them spaced apart so that you don't get the circuit cluttered. Use the extreme ends of plus and minus, not the same columns, for power and ground connections. Okay. We will get a resistor. Do you see this resistor here? This is just a 10 kilo ohm resistance. We will have this inserted between these 2 ports. Okay. Oh. Alright, now we'll get to complete the connections. We will just insert 2 more wires from the power supply point to the point here. And one more between this point and the ground. Alright, we will have the 2 nodes that we want to measure voltage at connected from here. Get that point out to the banana A. Do you see banana A here? You have banana A through D here. We will get 1 point from one end of the resistor to banana A. Okay? And from the other end, we will get 1 more to banana B. Now that we have between banana A and banana B, these are internally connected to these banana jacks that you see here. Okay? So we will connect one of the banana A's. We will take a banana cable like this and connect one to banana A, and the other end we will plug it in to the DMM portion, the V omega sign, where you have the V omega sign. We will connect it there for the voltage measurement, and the one below, the sign below it, is the COM, and we will connect the B, banana B, to COM. Now we are ready. As far as the circuit goes, we have connected a plus 15 volt to a resistor and completed it back to bringing it back to the ground, and we have hooked up a multimeter right across the resistance. Now we will see how how the software interface looks. Okay. Once you have connected this, make sure you have also turned on the power supply to the prototyping board. The power switch is right here at the right top corner. I'll turn it on here. Okay. Now we will turn and look at our computer screen where we have the instrument launcher. As you can see, to launch the NI ELVIS, you just go to the start program here. Go to start program. Go to start program like this. Then go to all programs, and then you have national instruments there. Go to national instruments, and under national instruments, come down, scroll down to reach NI ELVIS MX there. NI ELVIS and NI my DAC. And there you see NI ELVIS instrument launcher. Click on that. It brings up this menu, which is NI ELVIS instrument launcher. There you can find the first icon, which is DMM. Click on that. That brings up the digital multimeter. Okay. So this looks. This is the interface we have, and this should be sufficient to measure what we are interested in. As you can see, it has a DC steady-state DC voltage measurement, AC voltage capability, DC current, AC current, omega, which represents measurement of resistance, capacitance, inductance, diode connectivity, and connectivity, as you can see here. So let's do a voltage measurement. So we have the voltmeter connected there, and we will have now the device dev2 selected here, and we will just say run. And there you go. Wow, you have 15.697 volts displayed. Sure enough, we have a 15 volt supply there, so we can see 15.697 volts.